I want to start this particular tutorial with an equation, and what I'm going to do is I'm going to introduce the equation, and at the end of the tutorial I'm going to make sure that we understand what it means. And the equation is as follows: VE equals TV multiplied by F. Now you might be thinking, hang on, that doesn't mean anything, and I don't want it to mean anything at this point. If it does, fantastic, but don't worry. To be clear, the TV does not stand for television. It's a respiratory value, and we'll come back to it in a second. Now, in order to sort of like draw your attention in here and get us thinking about what this might represent, I'm going to get me ruler out. And here's me ruler, and I'm going to go for a little white colour. I think this is not white, it's a greeny white, and I'm going to draw a nice vertical axis. And then I am going to rotate that vertical axis. Let me bring that down to there. I'm going to rotate that vertical axis, and we are going to have our x-axis like this. Okay, so let's have a look. There's my, oops, there are my axes, and we're only going to be sketching here. And basically what I'm going to do is normal graphical stuff. I'm going to say that on our x-axis we have time, and our time is going to be in seconds. And on our vertical axis, on a y-axis, we're going to have volume, and our volume is going to be in litres. Okay, so we've got volume in litres, time in seconds. Okay, so that's what our axis labels are, and I'm going to introduce to you the idea of a spirometer trace. Now, to be clear about this, what we are going to do is we are going to plot a graph of the amount of air that is within the lungs when a person breathes in and breathes out, and throughout that process. So basically, as something goes up here and reaches a crest, that's going to be like the peak of breathing in. And when we breathe out, when it reaches the trough, this here is going to be sort of like our fully having breathed out in that particular breath. And what I'm going to do here is I'm going to draw a transverse wave. Now, as it's a transverse wave, folks, if you're a physicist, if you're good on your mathematics, you can use all the same properties of a transverse graph: your crest, your troughs, your amplitudes. And I'm going to talk a little bit about frequency. I'm going to talk a little bit about that in a few minutes' time. So, first things first, let's imagine we're at rest and we take a breath in. Our volume would go up. We have we have an intake, and then we're going to breathe out. And there, we're going to breathe in, we're going to breathe out, we're going to breathe in, we're going to breathe out. Now, this here, what I'm representing here, this, which I really should have done in green actually, this is tidal volume. And tidal volume is the amount of air breathed in and out per breath. And that's, of course, what we've got pictured here. And so far, along my transverse wave here, we have made 1, 2, 3 breaths in. So we can say, let's imagine that this was 15, let's imagine that this here was 15 seconds. We would say, okay, this person's breathing once every 5 seconds. They're going to breathe about 12 times in the minute, aren't they? Something like that. Now, of course, what happens when we start exercising? Let's imagine we start, I don't know, doing a training run or something like that. What's going to happen here is that our breathing is going to get deeper. So we go up to here, we go down to here, we go up to here, we go down to here. Now, let me do one more. We go up to here, we go down to here. Now, I'm not sketching these very well. Now, let's imagine that this here is 30 seconds. I don't know how my scale is going, but nevertheless, I have now breathed the same number of times in that next bunch of 15 seconds, in the 15 seconds block here. I've breathed 3 more times, but this time my tidal volume has gone up. How do we know that? Because from kind of the resting level, the peak is greater above and below. So our tidal volume has increased. Then if we get into sort of maximal exercise, what we might expect to see is something like this. And I'll go into sort of a green colour of this. Into maximal exercise, what we might expect to see is something like this. I'm going to redo that because that is nowhere near what I wanted it to be. Let me do that again. That was literally rubbish. So I'm going to go up, a little bit of a higher peak, down, up. Now, obviously, I'm free-handing this, but the point I want to make here to you is, can you see now that we've got a slightly greater quantity? Our tidal volume has gone up, but now we can also see, so our tidal volume has gone up, but now can you also see that in this 15 seconds here, this is now at 45 seconds perhaps, we have got 1, 2, 3, 4 waves that are in there. That means the frequency of how many times I've breathed has gone up. So we have got our tidal volume, which is how much air we breathe in and out, multiplied by how fast we breathe. What would that equal? It would equal VE, and VE, despite its letters, is called minute ventilation. So I want to be clear here. We have got minute ventilation equals tidal volume multiplied by frequency, and by frequency you're talking about breathing frequency. Sometimes we call it respiratory rate. So we have got minute ventilation multiplied by is tidal volume multiplied by breathing frequency, and that should make some kind of common sense to you, I would argue. It should be fairly commonsensical to you. And because we've got more crests and troughs in this 15-second period here, of course it means we are breathing faster. The other thing I want you to notice here is that when we exercise, we breathe deeper first and we breathe faster second. That is not accidental. That is how this works. Now, I'm not going to, if you want to know more about that, go into the mechanics of breathing type tutorials and you can learn all about that. Now, what I want to do is I want to start to think about some values, okay? So let's take tidal volume first. What would we expect the tidal volume of people to be? So tidal volume, okay? So the amount of air we breathe in and out. First of all, what we're going to do is we're going to say tidal volume at rest. And I want to look at two values here. I want to look at an untrained person, so someone who's, not an athlete, and someone who is an athlete, okay? What would we expect the tidal volume at rest to be for these different people? What would we expect that, excuse me, to be the case? So we would expect, for example, something along the lines of probably, we would expect something along the lines of about 500 millilitres here. So if we were to measure the actual rest to peak or trough scale there, we would have about 500 millilitres. Now, interestingly, for a trained athlete, we don't get much of an increase. It's going to be something just above 500 millilitres, okay? Which means that at rest, our breathing frequency at rest, if we had untrained, someone who's not an athlete, what we would be expecting to see there is something like 10 to 12 breaths per minute. And that should give you a bit of an indication as to how much minute ventilation an untrained performer is going to be taking in. I'm not sure why my pen is spinning like this, quite annoying. 10 to 12 breaths. 10 to 12 breaths. Whereas our trained performer, we would be expecting them to have probably in the region of the same, 10 to 12 breaths, give or take. Okay, now this is where it gets interesting. I just want to drag down a little bit further. Sorry about my pen sort of getting stuck at times. I just want to now talk about, that's meant to be yellow, I just want to talk about sub-maximal exercise. So let's imagine now that we are doing exercise here and it's some kind of training, run, jog, not maximal intensity. What would we expect to see? Well, when we do this, if we look at frequency, if we look first of all at our trained performer, we would expect that frequency would go up to maybe 15 to 20 breaths. But our untrained would go higher. It would go 20 to 25. Now, why is that the case? And it's for this reason. Because if we now look at, meant to be red, if we now look at tidal volume, if we look at trained, we would expect that to be in the region of 2 to 2.5 litres. Okay, whereas for our untrained, it of course is going to be lower. In this case, they're going to find, okay, the tidal volume is going to be 1 to 5 to 2 litres, something like that. So of course, the untrained athlete needs more breaths because their tidal volume is going to be a little bit lower. And therefore, obviously, you can calculate the minute ventilations based off that. We can do sort of 20 times, it could be up to about 40 litres for the trained performer, or even 50. And for the untrained performer, maybe if we take 20 multiplied by 1.5, of course, we might be looking there sort of like maybe something like 30 litres per minute, something like that. Now, what we're also going to do is we're now going to look at maximal exercise. What happens during maximal sort of power output? Well, the frequency for the trained performer, can go as high as 50 to 60 breaths per minute. But for the untrained, their breathing frequency will not. That is quick, by the way. But for our untrained, the maximum they're going to get to is sort of 40 or 50 breaths per minute. Meanwhile, if we start to think about our tidal volume again, for our trained, we're going to be expecting this to be in the region of 3 to 4 litres. That's meant to be a decimal point there. 3 to 4 litres tidal volume, and are untrained, we would expect this to be in the region of 2 to 3 litres. And again, you do the same thing. Now, again, you can start to calculate, well, if we've got 60 breaths per minute and we're taking, let's say, 4 litres, that is a massive quantity. That is 60 times 40. We are talking there about a quantity of air per minute, which could be in the region of even over 200 litres, in this case, 240 litres of air. That's a massive amount, as opposed to our untrained, who might be doing 40 breaths per minute, 2 litres per breath, and therefore might be in the region of 80 litres per minute in there. So that gives our minute ventilation. I want to now bring you back to the start point. We said that VE, minute ventilation, is tidal volume times frequency, and that is why those values matter. And start to think about now, what are respiratory adaptations to training? Well, one of the respiratory adaptations to training is that we can actually breathe faster at maximal exercise. Another adaptation to training is that our tidal volume is higher in trained athletes. That matters. Notice here, higher than here. Notice here, higher than here. So trained athletes have a higher tidal volume, and therefore the potential minute ventilation in maximal exercise is greater. Thank you.